Hi, and today we are going to study the concept of non-exact, non-homogeneous differential equation. In the previous video, we have seen how to find out the integrating factor if the differential equation is non-exact and if it is homogeneous. But what if the differential equation is non-exact and non-homogeneous differential equation? So let's take an example. So y times x squared y squared plus 2 times dx plus x times 2 minus 2 x squared y squared times dy, which is equal to 0. So here let's check whether this differential equation is exact or non-exact. So m is equal to x squared y cubed plus 2y, and n is equal to 2x negative 2x cubed y squared, and here we have, so delta m upon delta y is equal to x squared times 3y squared plus 2, and delta n upon delta x is equal to 2 minus 2y squared times 3x squared. So here we have 2 plus 3 times x cubed y squared, and here we have 2 negative 6 times x squared y squared. So here delta m upon delta y is not equal to delta n upon delta x, so the given differential equation is non-exact. And if you see the homogeneity of this equation, so here the power of x will be 2 and y will be 3. So power of x will be 2 and y will be 3, and overall power will be 5 here, and the overall power will be 1. So this equation is non-homogeneous. So if the given differential equation is of the form y times f of xy times dx plus x times g of xy times dy is equal to 0, then the integrating factor will be 1 upon m times x negative n times y. It is important to note that when the differential equation is non-exact and homogeneous differential equation, then the integrating factor will be 1 upon m times x plus n times y. So here the integrating factor will be 1 upon m is x squared y cubed plus 2y times x minus n is 2x minus 2x cubed y squared times y. So this will be 1 upon x cubed y cubed plus 2xy, and this will be a negative 2xy negative 2x cubed y cubed. So this will be equal to 1 upon x cubed y cubed plus 2xy negative 2xy and positive 2x cubed y cubed. So this positive and negative will get cancelled, and the integrating factor will be 1 upon 3 x cubed y cubed. And if you multiply this integrating factor with the given non-exact differential equation, then this differential equation will turn into an exact differential equation. Let's take another example. So a second example is if y times 1 plus xy times dx plus x times 1 minus xy times dy is equal to 0. So if we see the homogeneity of this equation, so here the power of y will be 1, here the power of x will be 1, and y will be equal to 2. So the overall power will be equal to 3. So this will be a non-homogeneous equation. non-homogeneous differential equation, and this equation is of the form y times f of xy times dx plus x times g of xy times dy, which is equal to 0. So if we see that whether this equation is exact or non-exact, so m will be equal to y plus xy square, and n will be equal to x minus x square y. So dab m upon dab y is equal to 1 plus x times 2y, and dab n by dab x will be equal to 1 minus y times 2x. So here we have positive sign and here we have negative sign. So dab m upon dab y is not equal to dab n by dab x, which implies that the given differential equation is non-exact. And the integrating factor in this case will be equal to 1 upon m times x minus n times y, which will be equal to 1 upon m is y plus xy square times x negative x minus x square times y. So this will be equal to 1 upon xy plus x square y square negative xy negative x square y square. And now this will be equal to 1 upon xy plus x square y square negative xy and positive x square y square. So this negative and positive will get cancelled, so it will be 1 upon 2 times x square y square. So this is the integrating factor for the given non-exact differential equation, and if you multiply this integrating factor with this non-exact differential equation, then the differential equation will turn into an exact differential equation. Now what if the differential equation is non-homogeneous, non-exact, and which is not in the form of y times f of xy dx plus x times g of xy dy, which is equal to 0. What if the given differential equation is non-homogeneous, non-exact, and which is not in the form of y times f of xy times dx plus x times g of xy times dy? So in this case, here there will be two possibilities. One, if 1 upon n times dab m upon dab y negative dab n upon dab x, if this is the function of x, then the integrating factor will be equal to e to the power integration of f of x dx. And if 1 upon m times dab n upon dab x negative dab m upon dab y, if this is function of y, then our integrating factor will be equal to e to the power integration of f of y dy. Now how to identify that out of these two equations, which of this equation we are going to use? So the term which has less number of terms will take the term which has the less number of algebraic terms outside of this bracket. So to get a clarity, we'll take an example. So what we are gonna do is, if the differential equation is of the form which is x square plus y square plus x times dx plus xy dy is equal to 0. So this first let us check the homogeneity of this equation. So here the power of x is 2, the power of y is 2, but the power of x is 1. So this is non-homogeneous. Now let's check whether this differential equation is exact or non-exact. So m is equal to x square plus y square plus x, and n is equal to xy. So delta m upon delta y is equal to 2y, and delta n upon delta x is equal to y. So as delta m upon delta y is not equal to delta n upon delta x, so this implies that the given differential equation is non-exact, and this differential equation is also not in the form of y rams f of xy times dx plus x times g of xy times dy, which is equal to 0. Here we can't take y common. So now here there are two possibilities, as I said, but as n has less number of algebraic terms, we are gonna make use of this equation. So 1 upon n times delta m upon delta y negative delta n upon delta x. We are going to find out this. So this is 1 upon n is xy, inside the bracket 2y minus y. So this is gonna be 1 upon xy, inside the bracket y. So this y will get cancelled, and we have 1 upon x, which is function of x, and therefore our integrating factor will be equal to e to the power integration of f of x dx. So e to the power integration of 1 upon x times dx, which would be equal to e to the power log x, since integration of f dash x upon f of x is equal to log of f of x, and we can write this as x. So when we multiply this into integrating factor with the given non-exact differential equation, then this differential equation will turn into an exact differential equation. Let's take another example. So xy cube plus y times dx plus 2 times x square y square plus x plus y to the power 4 times dy, which is equal to 0. So first let's check the homogeneity of this equation. Here the power of x is 1, the power of y is 3, overall power will be 4, but the power of y here is 1, and here we have the power of x as 2, power of y is 2, so overall power will be 4. The power of x is 1 and the power of y is 4, so this is non-homogeneous differential equation. Now let's check whether this differential equation is exact or non-exact. So m is equal to xy cube plus y, and n is equal to 2 times x square y square plus 2x plus 2 times y to the power 4. So delta m upon delta y is equal to x times 3y square plus 1, and delta n upon delta x is equal to 2 times y square times 2x plus 2. So here delta m upon delta y is not equal to delta n upon delta x, which implies that the given differential equation is non-exact. And here, as the number of algebraic terms in m is less, so what we are gonna do is we are gonna make the use of this equation. So 1 upon m inside the bracket delta n upon delta x negative delta m upon delta y. This should be the function of y. So let's find out this. So 1 upon xy cube plus y inside the bracket 2 plus 4 times xy square negative 3xy square plus 1. So this should be equal to 1 upon xy cube plus y inside the bracket 2 plus 4 times xy square negative 3xy square and negative 1. So we will come out with So we will come out with 1 upon xy cube plus y inside the bracket, 1 plus xy square. And now what we are gonna do is we are gonna take y common from this term, so 1 upon y times xy square plus 1 times 1 plus xy square. So these both will get cancelled, and we have 1 upon y, which is function of y. So our integrating factor will be equal to e to the power integration of f of y dy. So integrating factor will be e to the power integration of 1 upon y times dy, which will be equal to e to the power log y, since integration of f dash x upon f of x is log of f of x. So we can write this equation as y. So the integrating factor for the given non-exact differential equation is y, and if we multiply this integrating factor with the given non-exact differential equation, then that equation will turn into an exact differential equation. So this was all information regarding non-exact differential equation, and thank you for watching this video.